But anyway, we can get our energy out in different ways, like math. So does anyone have more questions? Then we'll just get started, because today, I've been saying this for like 3 days now, today we are for sure going to get to the basically hands down most beautiful proof of math. I think it's the most beautiful proof of math, the most beautiful I've seen, and I haven't really seen anyone argue against it. I think maybe some people are like, it's actually top 2. The point is, it's pretty great, and the other one we're also going to get to today. So let's get started with it. Before we get to that, though, we're saving that to the end as the kicker. Let's finish up talking about this whole even odd mess we've been talking about. So first of all, we are in section 4.7 still, which is indirect proofs. And that basically means contrapositive and contradiction. All the contras, which sound like a G.I. Joe villain to me, contra. But anyway, yeah, so that's what we're doing. And then last time, we kind of talked about how we've been using this fact. I'll write it down. We've been trying to prove that the opposite of being even is being odd, right? Like, we kind of use that fact, but nowhere have we proven it. It's not immediately obvious, right? The definition of odd or in even, that means n equals 2k for some integer k. In odd, that means n equals 2k plus 1 for some integer k. Or maybe I'll use t. The point is 2 times some integer plus 1. That's what even means, that's what odd means. But from this definition, it's not inherently, immediately, totally obvious that being even and odd are opposites. Right? To be an opposite, what I mean is it's the negation. So i.e., what we're trying to say here is, that for all n and z, the opposite of n being even is equivalent to n being odd. Right, that's what we're trying to prove. It makes a lot of sense to us, right? Like, even and odd are almost like go-to examples, not just in math, but in life, for things that are opposites. But why? Well, like why do they have to be opposites? Well, first of all, note this breaks down in saying that for all n and z, not n even implies n is odd. And for all n and z, n odd implies not n even. That makes sense. We're just breaking the biconditional into if thens. Now, so we really need to prove that if n is not even, it's going to be odd. And if n is odd, it's not going to be even. Now, one of these we actually proved last time. Can anyone enlighten me in the class?
It was number 2.
Yeah, exactly. Recall last time we proved that for all N and Z, we don't have N even and N odd. You might ask, wait, well, how does that relate to this? Well, remember that N odd implies not N even. Well, how can we break that down? Well, remember, this is equivalent to, like P implies Q is equivalent to not P or Q, right? So this is equivalent to not N odd, not N odd, or not N even, which by De Morgan's law is the same thing as not N odd and N even. The point being, if you show that every integer can't both be odd and even, then if an integer's odd, it's got to not be even. Because if it was, then they'd have an integer that's both even and odd. We know we can't have that. Does that make sense how we've proven this second part? Hope it does. So now all you have to do is prove the first part. That if n is not even, then it must be odd. And by the way, that's the same thing as saying that if we have not n even implies n is odd, that's the same thing as proving that not n even or n odd. Not n even is the same thing as n even or n odd. So proving that n not even implies n is odd is the same thing as proving that every integer is either even or odd. Does that make sense? And these two facts together are all we need, right? Like the idea of saying the opposite of n being even is n being odd, right? Like this original black conditional here, that's the same thing as saying that every integer is either even or odd, but not both. Because then you know if n's even, well, then it's gotta be, or you know that if n's not even, it's gotta be even or odd, but it can't be even, so it's gotta be odd. Hope that makes sense. So the point is, we're going to prove this. We're going to prove this right here, that if n's not even, n's odd, and that's the same thing as proving that that every integer must be even or odd. And once we've done that, we've proven this, and we've actually proven that being the opposite of being even is being odd. The thing we've been using a ton. It makes total sense, but it's actually not obvious. Any questions on the goal? Good. Now, technically, I've heard that when setting goals, it's good to write your goals down, which you just did, which is good. But it's not good to write it's not good to make your goal something that's like necessarily like an actual like number to hit or something like that, because you might fall short. Instead, you can't really control that. What you can't control is what you can do. For example, it's not good to make your goal like, hey, I'm gonna do I'm gonna be able to do 1,000 push-ups in an hour or something like that by the end of October. That's not a good goal. A better goal is that I'm going to improve my push-ups every day or something like that, because that's something you can do, or you need rest days, but you know what I'm saying. So anyway, but I believe in us, so let's not care about any of that.